This is the GCSE AQA chemistry topic, so due reward scientists will not need to consider what's coming up in this video. It's the final part of chemical calculations, and in this particular video we're going to look at volume of gases. As always, have a go at the tasks for yourself, pausing as you go, and then you get to see how you're doing. So in terms of what we're going to look at here, we need to be able to calculate the volume of a gas at room temperature and pressure if we're provided with mass and relative formula mass. Now, there is a really simple rule that we use at GCSE, gets slightly more complicated at A level, but we say that at room temperature and pressure, or standard temperature and pressure, 1 mole of any gas will occupy a volume of 24 decimeters cubed. So with that in mind, and with the blue box here, have a go at answering the questions below. And it really is as straightforward as it looks. So a volume of 12 decimeters cubed at room temperature means 12 divided by 24, I've got 0.5 moles of gas. If I'm looking at the next one, 6,000 cm cubed, well, I'm going to use my 24,000 cm cubed alternative here. That comes to 0.25 moles. For number 3, 0.25 moles, what volume will it take up, will it occupy? So we've got to rearrange the equation here. And on this one, we're going to say 24 multiplied by 0.25 gives us 6 decimeters cubed. But read the question carefully. In fact, it does want 6 decimeter cubed there, but that could be converted to 6,000 centimeters cubed. And finally, volume in centimeters cubed, would you expect 2 moles of gas to occupy? Well, 24 times 2 is 48 decimeters cubed, but I need to multiply that by 1,000 to get to centimeters cubed. And now let's move on to slightly more challenging ones. We've got here a car has an airbag inflated by the production of nitrogen. 70 grams of nitrogen are produced in a collision. What volume would that be at room temperature and pressure? Well, 70 grams is 2.5 moles. And if we know that we've got 2.5 moles and we know 1 mole occupies a volume of 24 decimeters cubed, I can multiply those two together and I get 60 decimeters cubed. Couple of quick questions for you to try to finish off. What volume of O2 would be needed to react with 150 decimeter cubed of methane? Well, this is actually really straightforward. 1 mole of methane reacts with 2 moles of oxygen, and we know that 1 mole occupies a volume of 24 decimeter cubed. So I need double the volume of oxygen. If I need 150 decimeter cubed of methane, I need 300 decimeter cubed of oxygen. And now let's try this one. And we can see here, I've already started the calculation, 48 decimeter cubed of nitrogen. So that means I've got 2 moles of nitrogen. There's a 2 to 3 ratio of sodium azide to nitrogen. And that means that I can work out that I've got 1.33 moles of sodium azide. If I know the number of moles and I can find its MR, which is 65, I can then find the mass, 86.6 grams. So the calculations that we're doing all relate back to the mole triangles that you've seen and the new 24 decimeter cubed per mole of gas. And it's about working out which bits of those you have and filling the gaps in to get to the right answers. That takes us to the end of the video and the end of this topic. Thank you for listening and goodbye.